beginnend No, sir. So yesterday we were doing problems from exercise 13.1. We did till problem number 30. There are two more problems that are left out. We'll complete it. So if the function f of x satisfies, so it is going to satisfy this condition. Limit x tends to 1, f of x minus 2 divided by x square minus 1 is 5. Then we need to find what is the value of limit x tends to 1. So how to do this?
So that means left limit equal to right limit equal to function value, sir.
Yes, we need not do that. No? Actually, they directly told it satisfies this condition. Then how do we proceed? So we are expected to calculate what? The limit of the function at x is equal to 1. So, see, limit x tends to 1, can I write it as f of x minus 2 divided by limit x tends to 1, x square minus 1 is pi.
Yes, sir.
So I will take this to the other side because here if I substitute the limit, what will happen? It will become infinite. So something by infinity cannot be a finite value on the right hand side. It should be a 0. So limit x tends to 1, f of x minus 2 is equal to pi into limit x tends to 1, x square minus 1. Now if I substitute the limit on the right hand side, what will happen? It will become pi into 0. So left hand side, can I write it as limit x tends to 1 f of x minus limit x tends to 1 2.
Yes, sir.
So when I write this, see what is going to happen. Then limit x tends to 1 f of x minus limit x tends to 1 2 is how much? It is just 2. Right?
Yes, sir.
So this will be equal to a 0, which implies limit x tends to 1 f of x is how much?
It's 2.
That's what they're expecting. So the answer to this is 2. So here you need not find the left limit and right limit, all those things. Because they already told it satisfies. Clear?
Yes, sir. Clear.
Make a note of it. Just a minute. Yeah, right. Let me know once you're done. Shall I move on?
Completed.
Yeah. Now listen. 32nd question is, if f of x is equal to mx square plus n when x is less than 0, nx plus m when x is between 0 to 1, nx cube plus m when x is greater than 1. Okay. For what integers m and n does the limit extends to 0 f of x and the limit extends to 1 f of x exists. Okay. So what do you mean by existing? Left limit should be equal to right limit should be equal to function value. So limit extends to 0 minus f of x is how much? That is limit h tends to 0, f of 0 minus h. Accepted? So limit h tends to 0, f of 0 minus h means which function should I use? So at x is equal to 0, it is split into two parts, right? Which one should I use? Zero minus means less than 0, right? Guys, if you're not going to speak,
Yes,
I'll just
mx
do
square
it.
plus n, sir.
Yes. It is mx square plus n. So m into, in the place of x, it will be 0 minus h the whole square plus n. So when you substitute h is equal to 0, it will be m into 0 plus n, which is n. Let me call this as equation 1. Similarly, I'm checking limit extends to 0 plus. So since they told limit exists, then the left limit should be equal to function value. What is f of 0?
0, sir.
No, f of 0, look at the function. No, what function is defined at x is equal to 0?
For nx plus m, sir.
Yes. So it will be n into 0 plus m.
Will be m, sir.
Yes. That will be equation number 2. Similarly, when I check limit extends to 1 minus, what will I get? Actually, I need not check 1 minus because they have told limit extends to 1, f of x exists. So I will directly calculate f of 1 because I have equal to 1. So what is f of 1?
Nx plus m, sir.
So n into 1 plus m, that is n plus m. Similarly, limit extends to 1 plus f of x is how much? That is limit h tends to 0, f of 1 plus h. So f of 1 plus h means what should I write?
Nx cube plus m, sir.
Yes, n into 1 plus h the whole cube plus m. If you take h tends to 0 and substitute it here, I will get the answer as n plus m. That is 4. So, for limit at 0 to exist, 1 should be equal to 2, which implies n is equal to m. Correct? Similarly, for limit at 1 to exist, what should happen? M plus n should be equal to. So m plus n will be equal to m plus n and n will be equal to m for all values. So what did they ask? For what values of m and n does both exist? So whatever is the value of m and n, this the function is going to have its limit existing at 0 and 1. But
Whatever be the whatever number it is.
Whatever number it is, whether it is 1, 2, 3, but it has to be an integer because they told m and n are integers. So the answer will be for all integer values or integral values. I'm not sure how the answer is given at back. For all integer values of m and n, the given conditions will get satisfied. Am I clear? I hope you understood why I told for.
Yeah, here I didn't understand why we use the function value for f is 0 and f is 1, actually.
Because, see, for limit to exist, what is the condition? Left limit should be equal to right limit is equal to function value.
Yes, sir.
Right. So they themselves have told that limit extends to 0 exists. So the advantage is when x is less than 0, I will find the left limit of it.
Yes,
Less than
sir.
0 means left limit, 0 minus. I have a function value at x is equal to 0. No, for the limit to exist, left limit should definitely be equal to function value. No, so I use that condition. If you want, you can use 0 plus and also see, you will get the same answer in. Sorry, you will get
So
the
here
same
it's not
answer.
necessary to get right limit for this, sir.
I'm not saying it is not, yeah, it is not necessary because they have told it is existing. They didn't ask us to prove. See, had the same question been to prove, then you need to take the right limit and also show it. Okay.
Okay, sir, understood.
Yeah, yeah. Okay, so these are all the problems that are related to limits. With this, we are done with limits, right? I hope there is no doubt. Shall I proceed to the next part of the chapter?
1 minute, sir. 1 minute, sir.
Yeah, make a note. Make a note.
Done, sir.
Okay. Now listen. So we are done with limits. So the name of this chapter is limits and derivatives, right? Now we will see what are derivatives. Okay. So till now I told you by you finding out whether the limit existing, whether the limit is existing at a point or not, what does it have to tell about a function? So limits mainly speaks about function only, right? We have been seeing function only everywhere. Only thing is the different values from the domain had been used. So when I say limit exists, I was using a word continuously. What is it? Repeatedly, I used one word, which I told you learn next year. So when someone says limit exists, what are they indirectly trying to tell us? They are trying to tell us that the function is continuous. Else, it is discontinuous. So one thing is clear: limits is mainly applicable only for a function. In a similar way, derivatives is also applicable to a function only. But by finding a derivative, what exactly are you finding? Finding is what we are going to see in this chapter, in this particular part. Okay. So before I proceed to derivatives, I just need to ask some questions. So if I have x and y axis, let's say I have a line that is line drawn, and I'm saying the line cuts the x-axis and it is making an angle theta in the anti-clockwise direction. If I find a parameter called as tan theta, okay, tan theta is a trigonometric value. With respect to a straight line, what does this tan theta mean?
It means slope, sir.
It is the slope of that line, right? So we are clear with the word slope. So slope is the slope here. So when I talk about slope, here comes an important question. When I talk about a slope, is it possible for me to define the slope only for a shape which is a straight line, or will I be able to define a slope for a parabola also? Will I be able to define a slope for a hyperbola? Will I be able to define? Is a question that comes in our mind. Are you guys able to understand? So in the straight lines chapter, what we use the concept of slope, but the concept of slope was used only for a straight line. We never use the concept of slope in conic sections. If you clearly observe, nowhere I would have told, right? Because
Yes.
slope is a parameter which is related only to a straight line. Okay. Now comes an important question. If at all it is defined only for a straight line, then if I need to define the slope for a parabola, then what am I supposed to do? Okay. So it is going to exist, but how is it going to exist is what we are going to see. Okay. Try to understand the concept, guys. That's where derivatives is going to help us. I'm reiterating, for you to be good with calculus, you guys need to practice functions. I'm not sure how much of practice has gone in. So if I take a graph, let me say the name of this graph is y is equal to f of x. Okay. So I am taking a point c comma 0 and I'm taking a point c plus h comma 0. Then what is going to be the distance between these 2 points on the x-axis?
H, sir.
H. Okay. Remember in calculus, whatever value of h you're using, no, it is a very small value. H will always tend to 0. Means its value will be somewhat like this, 0.00000. It will be this small. Okay, that they are very close to each other. Since we cannot draw it like that, I've I've given some distance between them. Right. So I hope you're able to visualize. Now see, for better understanding, what I will do is register one point in your mind. H is a very small distance. C plus h comma 0, where the distance between C and C plus h is how much? It is h. Correct? Now comes the important question. What will be the value, the coordinates of the point on the graph? It will be C comma what will be the corresponding point? What will be the red dot? What will be the coordinates of it? The x coordinate will be C. What will be the y coordinate? Y is equal to f of x, guys. What is going to be the y coordinate?
F of X, sir.
F of, it's not f
F
of
of
x.
C, sir.
It is f of c. Because you have to substitute this x value in that, no? That is the meaning. That is the meaning of function
Yes.
value. So what will be the corresponding point here? Now you will understand. It will be c plus h comma.
F of C plus H.
That's it. Now understand. I've taken two random points on what? On some curve y is equal to f of x. It's not a straight line anymore. But from the basics of straight line, I know for me to draw a straight line, the minimum number of points that I require is how much?
2, sir.
So 2 points are required, right? So I already have 2 points on this curve. C comma f of c and c plus h comma f of c plus h. So when I join these 2 points, I have a straight line. When I extend the straight line, I'm able to see that it is cutting the x-axis, or I can say it is making an angle theta with the x-axis. Even if it is not cutting, I can extend it virtually and see it is cutting an angle theta. Now tell me a question. So now answer my question. What is the name of line AB? What is line AB called as? Listen, guys. If I have a curve, I'm explaining with circle because you would have heard these terms. So with respect to a circle, if I draw a line segment which is internal to the circle joining 2 points, what is the name of that line segment?
Chord, sir.
It's called a chord. So chord is a line segment, means it has a fixed length. if I extend this if I draw a line which is cutting the curve at 2 points, what is the name of that line? It's called a secant, right? Similarly, if I draw a line which is cutting the curve only at 1 point,
Tangent.
yes, it's called a tangent. All these terms are known to you. Now I'm raising an important question. Now you can forget about chord because chord is a line segment. Now I'm talking about a line. So the line AB that I've drawn for this curve, is it a secant or a tangent?
It's a secant, sir.
It's a secant. Right? No doubt in that. Now comes a question. See, look at the way I'm going to draw. Okay. Now you got a clarity of what is secant, right? I'm reducing my pen size. Wait. See, I'm drawing a line like this. This is a secant. You're able to see it, right? Similarly, I'm drawing another line. That is also a secant. Right? Are you able to understand what I did? So, how will you find whether a given line is a secant or a tangent?
Depending upon the points that it intersects a circle.
Yes. So, if a line is cutting the curve, don't worry about circle. You can use the word curve. Circle I explained because you would have heard. Okay, it can be for any curve. So, if a line is cutting the curve at more than 1 point, then it's called a secant. Okay. But if the line is touching the curve at 1 point, it's called a tangent, right? So if you observe the secants that I've drawn 1, 2, and 3, if you observe the difference between the first, second, and third secant, what is that you're able to notice?
Distance between points decrease.
The distance between the points is decreasing. So if I keep drawing the secants like this, will I be able to draw a particular secant which will almost appear like a tangent? I'm repeating it. Listen to it carefully, okay? If I keep drawing such secants, if I draw infinite number of secants, see, for example, this is a circle. I'm drawing a secant like this. See, distance is more. Distance has decreased. Right? If I ask you about the third secant, if I zoom it out, okay, if I zoom it out, is it not appearing like a tangent? It is not
Yes,
a tangent, but it will appear like a tangent. So from this, what I'm trying to say is, if I want a secant to appear like a tangent, then the logical answer is the distance between the 2 points internally to the curve. The distance between distance between 2 points where the secant is cutting on the curve should keep decreasing. That should keep decreasing in such a way. So when I zoomed out, are you able to see? I have completely zoomed out. Are you able to see this? The fourth line is almost appearing like a tangent.
Yes, sir.
You're able to visualize, no? So what I'm going to do is, listen to this carefully. This is where the definition of derivatives is going to come. So when I say line AB is a secant, then I can define the slope of line AB. So slope of line AB is y2 minus y1 by x2 minus x1. See, I have the coordinates of point A and B. Right? So what is the slope of line AB? Tell me. It is f of c plus h, that is y2, minus f of c divided by c plus h minus c, that is going to give us h. That is x2 minus x1. Am I clear with this? So this is the slope of line AB, which is nothing but slope of secant. Now, when can the secant become a tangent? When can the secant
H becomes 0?
Excellent. H should not become 0. H should tend to 0. That is, if I bring this, see, I'll keep A fixed. I can move this point B, right? If I move B here, then when I keep drawing the tangents, when I keep drawing the secant, there will be one particular point where that secant will appear like a tangent. That is going to happen when the value of H is very, very small. Okay. So if I add a limit to this value, limit H tends to 0, f of C plus H minus f of C divided by H, then this is no more slope of a secant, rather it will become a slope of a tangent. Does it make sense? Right. So diagrammatically we visualize. So when the distance between A and B is decreasing such that the distance between A and B is approximately 0, then the secant is going to appear like a tangent. So mathematically, when can I say that approximately 0 is going to happen? Only when I apply a limit to it. So limit H tends to 0, f of C plus H minus f of C by H is still a slope, but slope of whom? It's not a slope of, it's not a slope of secant anymore, it's a slope of a tangent, and the slope of this tangent is what is called as dy by dx. This is the actual meaning of derivative of a function. So the conclusion here that I'm trying to tell you is, whenever someone says you're finding the limit of a function at a particular point, indirectly they are speaking about the function. They are speaking about the continuity of a function. So when you find the limit, it will give you the information about a function being continuous or not. Similarly, if you are differentiating a function at a particular point, what is it going to give you? When I give you a question, I give you a function, I say differentiate it. What is that I'm indirectly asking you? I'm indirectly asking you to find the slope of the tangent to that function at that point. Am I clear?
If they ask for a derivative, that means that slope of the tangent to the function.
Yes,
sir.
exactly. So anyways, the application, you will see it next year. See, this point, nobody will explain you in 11th standard. They will just say formula, there is a formula applied, you will get the answer. That's not the thing. You need to understand the reason. So derivative means finding slope of a tangent. That is the meaning. Limit means finding the continuity of a function. Wherever you want, please make a note of it. This is the life of calculus. This is where calculus is going to start. You will understand it when you do this. I'll prove it and show. I'll actually explain what is the meaning of this also. But tell me one thing, are you clear with this point? Till here, am I clear? Is there any confusion that you have?
Yes.
Everyone?
Yes, sir.
Okay. Shall I proceed then?
Just 1 minute.
So, yeah, please make a note of this.
Done, sir.
So write down the definition of derivative. Dy by dx is equal to derivative of f of x with respect to dx. See, both mean the same. This is also equal to f dash of x, or this is also equal to y dash. Everything means derivative only. So how you read is derivative of y with respect to WRT means with respect to x. That is how you read. So whenever you are differentiating something, you need to differentiate a variable quantity with a you need to differentiate a dependent quantity with an independent quantity. Meaning of it is, when I write y is equal to f of x, in functions itself we discussed, out of y and x, which is dependent and which is independent?
Y is dependent, sir.
Y is dependent on x. Whatever is inside that f, whatever is the variable that is present on the right hand side is independent, because we are free to substitute. So whichever value you give is going to decide the value of y. So y's value is decided by us. So whichever value you are free to substitute is called as an independent variable. So here what I'm trying to say is, when you write dy by dx, You're differentiating. You're finding the derivative of a dependent variable with respect to an independent variable. That is how you need to look at it. Clear? Does it make sense?
Yes, sir.
So the answer to everything is, see, these are all the different ways of writing. You write it in any way, it means the same. The meaning of any one of this is equal to limit h tends to 0 f of c plus h minus f of c, the whole divided by h, and this is called as derivative of y with respect to x at point x is equal to c. Okay, so what I'm trying to say is you will put a line like this and you will write x is equal to c. See, all these things you will not do it now. Okay, you will just do a simple differentiation. That is, you will learn how to use the formula in this exercise. But I'm giving you all the inner meaning so that you don't have confusion. If there is anything that you're not able to understand, please ask. So what I'm trying to say is dy by dx, if you put a line like this, that line is read as at whatever point you're trying to find the derivative, that you need to write it at the bottom, x is equal to c. So you read it as derivative of y with respect to x at x is equal to c is equal to limit h tends to 0 f of c plus h minus f of c divided by h. Okay.
For example, if x is equal to a there, so that means it will be f of a plus h minus f of a, sir.
I think in your textbook they have given a plus h. Your textbook, that is what is given, a plus h minus f of a divided by h. That c is some number. It can be x is equal to 5, x is equal to 4, something. Okay. So this is derivative at a particular point. Means you're fixing at which point you're interested to find the derivative. Sometimes what will happen is you can find the derivative at a general point. So derivative at general point, if I call it as x, general point is obviously x, right? Is given as dy by dx, you will not put that line at all, is equal to limit h tends to 0 f of x plus h minus f of x the whole divided by h, and this has a name called as first principle of derivatives. So this year they will ask you find the derivative of a function using the first principle of derivatives. They might ask you a question like that. Okay, at that time you need to use the formula. So what is the difference between the previous one which I gave and this one? In the previous one, what is the difference, guys? Look at it, do a comparative study. What is varying? So in this one, I gave a specific point C, whereas in this case, it is a general point X. So you can ask me, when should I call it as first principle of derivative? Will you use it in a specific? Will you use it in a particular case or a general case?
A general case, sir.
In a general case, we call it as first principle of derivative. Okay, though they both appear to be same, you need to understand the differentiating factor.
So, sir, the only difference is when that line is given, that's when it's a particular case.
They will
Otherwise,
not
it's
give
a
it.
general.
I'll tell you everything. They will not give you any line. They will only give you the function. Okay, I'll tell you what they will ask us. This is how the questions will be. Find the derivative. Derivative is the output of differentiation. See, the operation that you're doing is called as differentiation. The output is called as a derivative. Find the derivative of a function, some random function I'm taking, for example, x cube. Find the derivative of the function x cube at x is equal to 1. If they ask that, then the meaning is you're doing this. If they just say find the derivative of the function x cube, then you're actually doing the bottom one. But if you observe, they both are almost the same. Except the fact that for you to use the first one, you know the value of x. X is equal to 1 is given. So you use 1 plus h minus f of c. You're able to understand? For the denominator, what will you do? For the bottom one, you use f of x plus h minus f of x. Anyways, I'll show you all those things.
So that means they give a value for this thing, then we use the above one.
Above one. Actually, you do not use that also. By using that, you will get an answer. But see, this is the basic definition of derivative. This I have to explain. You will not use all these things. What we will do is, we will use the general formula, the so-called first principle of derivatives. We will already have a ready-made formula. Using this, we will derive certain formulae and have it ready to use it in the problem. You will not sit for every problem and do this thing. Okay. But when the question comes at x is equal to 1, you need to understand that the back-end process through which you actually got the answer is using this formula.
Okay, sir.
Okay, so what I'm trying to say is you will have a ready-made formula. You need not worry about it. See, like how we do in trigonometry, sine of a plus b is equal to sine a cos b plus cos a sine b. From that, we derived sine 2x is equal to 2 sine x into cos x, right? It's actually a ready-made formula. You can use it anywhere. We don't sit and do sine 2x as sine of x plus x and then we start the process. We don't do it like that. You're able to understand? In a similar way, here also we will have a set of formula that we will derive using the first principle of derivatives. Then I'll teach you how to use it.
Okay, sir.
Okay, shall I proceed? Yeah, shall I proceed, guys?
Yes.
So listen. So first, I'll not say find the derivative. Now I'm going to derive the formula and show you. Derivatives of the functions. First, f of x is equal to x power n, where n is not equal to, n can be anything, where n is an integer, okay, or it can be anything actually. F of x is equal to x power n. I'm using this. Now see. So I'm going to find the derivative of the function f of x is equal to x power n using the first principle. Look at the way I'm going to do. So concentrate. So what is the first principle state? Dy by dx. So they're actually asking what is to find is derivative of f of x with respect to x. That is derivative of x power n divided by x. Sorry, derivative with respect to x. That is the meaning. Okay. So how to do this is, what does dy by dx tell us? So always remember f of x is y. So dy by dx is what? Limit h tends to 0. F of x plus h minus f of x the whole divided by, sorry, h. So I just applied the formula, nothing else. Okay. So f of x plus h means what should I do? In the place of x power n, what should I write? Does it make sense? It's just like how you deal with polynomials. I give you a polynomial, I ask you what is p of x plus h. Wherever x is there, you substitute x plus h. So x plus h the whole power n minus, what is f of x?
X power n, sir.
X power n divided by h. Be confident. Now see. So this will be equal to limit h tends to 0. X plus h the whole power n. What is the formula? nc naught x power n plus nc1 x power n minus 1 into h plus nc2 x power n minus 2 into h square plus so on minus x power n the whole divided by h. Am I clear, guys? So what is nc naught? The first two variables, at least we don't have a problem. What is nc naught? nc naught is 1. So nc naught is 1. So x power n plus nc1 is n into x power n minus 1 into h plus nc2 is n into n minus 1 by 2 into x power n minus 2 into h square. Beyond this, we need not do. Plus so on minus x power n the whole divided by h. So what gets cancelled? So what gets cancelled? Yes, x power n is gone. Right? Now, if you observe, what is common in the numerator? H into, see, if I substitute h tends to 0 in this step, what will happen is, numerator will be 0, denominator will be 0. 0 by 0 form, I cannot solve it. So I'm taking h common, n into x power n minus 1 plus n into n minus 1 by 2 into x power n minus 2 into h plus so on. It keeps on going, the whole divided by h. Just go through these steps and let me know if there is any doubt. So, I believe there is no doubt, right? Now see, h and h will get cancelled. From this, I can say limit h tends to 0. What is that I'm left out with? N into x power n minus 1 plus n into n minus 1 by 2 into x power n minus 2 into h. The next term will be nc3 x power n minus 3 into h cube. Actually, it will be h square because I've taken out h. Right? It keeps on going till the last term, which is going to be h power n. Correct? So when I substitute the limit here, what will happen? The first term alone is saved because it doesn't have any relation to h. N into x power n minus 1 plus what will happen to the terms from here to here? So when I substitute h tends to 0,
Be
there is a
0.
0. It will be 0, which implies derivative of x power n with respect to x is equal to n into x power n minus 1. So those who have used it in physics, now you will understand why it is actually so. What are the reason behind you using that formula? Did you guys understand how it has actually come?
Yes, understood, sir.
So those who have not used or forgot, don't worry, I'll explain how to use them. So what I want you people to remember is derivative of the function x power n is given by n into x power n minus 1. Right? So make a note of it. Now listen guys. Some examples are find derivative of, I'll randomly give you some functions, okay? X square, x cube, x square at x is equal to 1. Well, instead of x cube, I'll take it as x power 5 by 2. Now tell me. So how to do the first one? So solution is, for the first one, derivative of x with respect to x is how much? So derivative of x with respect to x is x power 1. So what is the formula? N into x power n minus 1, where n is the power to which x is raised to. So in this case, 1 into x power 1 minus 1. So 1 into x power 0. Answer will be 1. Am I right? So remember, derivative of x with respect to x is always 1. You can actually remember it like a shortcut also. I just explained what is the reason for it. Second, d by dx of x square is how much? N into n is 2. N into x power, right? X power how much?
1.
2 minus 1. It will be 2x. Clear? Third one. You guys tell me what is the answer for x power 5 by 2?
5 by 2 into x power 3 by 2.
It is 5 by 2 into x power 3 by 2. Because x power 5 by 2 minus 1, which is 3 by 2. Right? So all these derivatives, if you see, did you find at the general point? Did you find the general derivative or a particular derivative?
General derivatives.
You found the general derivative. But if you look at the fourth question, wherever this preposition at comes, you are finding for a particular value. I'll also explain what is the meaning of it. Okay. So d by dx of x square at x is equal to 1. What is the meaning of this? First, you differentiate and substitute x is equal to 1. Don't substitute x is equal to 1 and differentiate. You should not do that. First differentiate, then substitute the value. What will be the answer? 2 into 1. Answer will be
2.
2. Now we need to understand what is the meaning of this 2. Okay. Concentrate, guys. So if I take a graph, what shape does the function x square take? Y is equal to x square. Recollected from conic sections. Y is equal to x square is what? It's an upward parabola. Okay. So y is equal to x square is an upward parabola like this. What is the point they've given? X is equal to 1. So x is equal to 1 is somewhere over here. Okay, I'm randomly taking. So 1 comma 0. When I draw a line perpendicular, I will be able to find a point on the curve. What will the point on the curve be? 1 comma. So what is the function, guys? Y is equal to x square. In the place of
So
x,
y
if I
equal to
substitute,
1.
so y is also equal to 1. 1 comma 1 is a point. Okay. Now listen carefully. The meaning of derivative of x square at x is equal to 1 means at this point 1 comma 1, if you draw a tangent to this curve, then the slope of this tangent is 2. That is the meaning. Okay. Suppose if I extend the question like this, find the derivative of x square at x is equal to 4. Or I will say x is equal to minus 1. Or let's say minus 2. You guys tell me what will the answer be. First differentiate it. 2x at
Minus
x
4,
is equal.
sir.
So minus 4. What is the meaning of this? So you have a point minus 2 here. So my wait, let me take it. So you have a point minus 2 here. What will be the corresponding point on the graph? Minus 2 comma.
Minus 4.
Why is it
4,
minus
sir.
4?
It's only 4.
It is 4. Okay. So what is the meaning? At this point minus 2 comma 4, if you draw a tangent, then slope of tangent is how much?
and minus 4, sir.
Now is it clear?
Yes, sir.
So this is the meaning of, so when you find the derivative at a particular point, you're actually finding slope of whom? Slope of the tangent drawn to the curve at that particular point. So the best example for this is derivative of x with respect to x. So what is the graph of derivative of y is equal to x? Y is equal to x is a straight line passing through origin, and I've already told you it's an identity function. And what will be the value of theta here? 45 degrees. Tan 45 is always 1. So in this question, is there an option for you to find the slope at a particular point? So for this question, if I put a statement like this, find the derivative of x with respect to x at x is equal to 5, what will your answer be?
For which question, sir?
For the first one. For the first one, whether you find at 5, whether you find at 6 or 7, anywhere the slope is going to be 1. Because slope of a straight line is always a constant, whereas slope of a curve which is bending will change from point to point, because when you draw the tangent, the tangent will get bent according to the curvature. Guys, are you able to understand all these concepts? I'm just trying to connect all the dots. Okay. So this is all about derivative of x power n. Now we will look at second function. We will take the function y is equal to sin x. So you need to find derivative of sin x with respect to x is equal to what? So what is the answer, guys? You people already know. Most of you already know. It is cos x. Okay. But how it has come, let's concentrate. Let's try to find out. So dy by dx is what? From the first principle of derivative, dy by dx is equal to limit h tends to 0, f of x plus h minus f of x the whole divided by h. So limit h tends to 0, f of x plus h, what is the function? F of x is sin x. So what will f of x plus h be? Sin of
x plus h.
Sin of x plus h minus f of x is how much? Sin x the whole divided by h. So can you check if you can directly substitute the value 0? If you substitute 0, what will happen? This will become sin x. This is already sin x. Sin x minus sin x. 0 by 0 is not defined. So what we are going to do is limit h tends to 0. What is the formula for sin c minus sin d? There is a formula for sin x minus sin y. If you revisit trigonometry, it is given as minus 2 sin of... Sorry. It is not minus. It is 2 cos of x plus y by 2 sin of x minus y by 2. Okay. So here it will be 2 sin of x plus h plus x divided by 2 sin of x plus h minus x divided by 2 the whole divided by h. Correct?
Of cos x plus h by 2.
I'm sorry. It's cos. Right. So limit h tends to 0. 2 cos of 2x plus h by 2 sin of this and this will get cancelled, h by 2 divided by h. Okay. So limit h tends to 0, sin of h by 2. What should be in the denominator for that value to come out as 1? So what I'm trying to say is this 2 will come out of the limit. It's a constant. So 2 into...
Should be h by 2, sir.
Yes, we will see that. 2x plus h divided by 2 into, can I write it as limit h tends to 0, sin h by 2 divided by h. Right? I just split the function. So I use the concept limit h tends to 0 f of x into g of x is equal to limit h tends to 0 f of x into limit h tends to 0 g of x. So it is sin h by 2 here. So what should be in the denominator? As you told, it should be by 2, and I'm compensating it with 2. Right? Now substitute the limit.
That 2 is 1 by 2, no, sir? We are multiplying.
Wait, I'll write it like this. You will understand it. So h by 2 into 2.
Okay, sir.
Okay. So 2 into, now substitute the limit. It will become cos of 2x divided by 2. Correct? H tends to 0. So if I put 0, h will become 0. 2x by 2 is left out. And what will this whole value give us?
1.
It will give us half. Because there is a 2 extra, no? Limit h tends to 0, sin h by 2 by h by 2 is 1. But you
Yes,
have
sir.
a 2 in the denominator. So 1 by 2. This 2 and 2 will get cancelled. This 2 and this 2 will get cancelled. What is that you're left out with? Cos x. That is why derivative of sin x is cos x. Clear?
Yes, sir.
Make a note of it. Let me know once you're done.
So we did that h by 2 only in the sine one, right? So we didn't use that thing on the cos one.
No, cos we
Divide
don't
by
need.
2.
Because cos we don't need it because limit extends to 0, cos x is 1 only.
Okay, sir.
But for sin x, what will happen? Sin x and denominator you have x. That value is when you substitute limit extends to 0 is 1.
Okay, sir. Understood.
Okay. Yeah. Clear?
Yes, sir.
So this is the derivative of sin x. So next class, we will see the derivative of remaining functions and I'll tell you how to solve the problems. Maximum 2 more classes, we'll complete this chapter also. Okay. Start practicing. If there is any doubt, you can approach me personally. Just wait for a minute. Don't log off.